Okay, here are two examples of improper integrals. So this one obviously is an improper integral because there's an infinity there. So you should do the integral. You could do this integral by doing tabular integration, plus minus d integral, and x differentiates to 1, 1 differentiates to 0, and then you get a 0, you stop, e to the negative x integrates to negative e to the negative x, integrate again, e to the negative x, plus, minus, plus. Then multiplying like that gives you the integral as negative x times e to the negative x, then minus e to the negative x. Now you plug in infinity and 0. Oh, but wait, we decide not to do that. We always want to assign a letter for infinity and take limit of a going to infinity. That's the way we decide to do it. Okay, let's further calculate this. This is limit a going to 0 to infinity of negative a e to the negative a minus e to the negative a, and then you have to minus 0 times e to the 0, which is a 0, and then minus e to the 0. When you plug in infinity to this e to the negative a, you get e to the negative infinity. What is e to the negative infinity? That's 1 over e to the infinity.
You would just like plug in 100 and keep going closer to 0.
Yeah, if you plug in some big number here, e is like 2.7, so 2.7 to the 100th power, that's an immensely big number. So it's 1 over infinity, which is 0. On the other hand, this one here is a bit harder to think. So let's just focus on this one. It's really limit a going to infinity, and let's rewrite this as a over e to the a, because then it's a fraction. And pull the minus outside. This is 0, that's 0. This one is negative of 1. Anything to the 0th power is 1, so that's going to be 1. So it'll be plus 1 here. And we'll only need to figure that limit out. Okay. Now when you put a to infinity, this will be infinity. What about the bottom? E to the infinity is?
1 over infinity says 0.
No. Itself. E to the infinity is infinity. Okay? This is infinity. So that this thing looks like infinity over infinity type. Why am I mentioning that?
Because we can use L'Hopital's rule.
Because you can use L'Hopital's, right? Which means you can differentiate the top, which gives you 1. And then if you differentiate e to the a, it's still e to the a by L'Hopital's. And then again, it's 1 over e to the infinity, which gives you 0, just like what we said. So that's 0 plus 1, which is 1. Such integrals will be pretty important later in your engineering courses, because when you solve circuits, you end up solving some differential equation which requires Laplace transforms, and Laplace transforms are defined in this manner. So we're never going to discuss it in this class, but let me just say Laplace transform of a function of t is multiply e to the negative st and you integrate by t from 0 to infinity. So that's the calculation that you have to do to solve some differential equation. I guess you don't even know what differential equation means, but it's some really hard math, okay? And when you get to differential equations course, which is like 2 more math classes after this, in that class you will be solving some integrals like this one, so you will definitely have to review things like that. Okay, now let's talk about the second example. The second example doesn't look like an improper integral at all, right? But why is this an improper integral? Can somebody explain?
Because that's ln.
ln doesn't have to be improper.
ln in the denominator.
So what?
It's going to make it more difficult.
It's okay. Improper means what? When you have value becoming infinity inside this interval from 0 to 1, right? So this value of the function, if it's infinite, then it's improper. And those places where you get infinity are the places that you have to be careful. You have to assign letters and take limits, okay? So when does this thing become infinity?
When we set the integral from 0 to infinity, or 0,
no, it's 0 to 1. 0 to 1. When x varies from 0 to 1, look at this function. When does this function become infinity? That's my question.
So if you do the integral, it becomes -1 over...
No, I'm not talking about what happens after you integrate. This has nothing to do with calculus.
Okay.
All I'm asking you to figure out is what happens to this value, the value of the function, when x becomes some number. Is there any value in here where
0.
this will be undefined? That's my question.
0.
0, of course. 0. When you plug in 0, what happens?
Oh, 0 times something
0
else.
times ln of that. ln of 0.
Yeah, so you have 1 over 0, which is undefined. And since it's in the interval 0 to 1, this really should be thought as like 0 plus your... See, at 0, this function is undefined. At 1, actually, this function will be undefined as well. But anyways, so you can't really go to 0, so it should really be thought as this left bound is like a, and a is sent to 0 from the positive side. And this right bound is called, we're going to assign the letter b, and it will be sent to 1 from the left side. But why is this also not defined? When you plug in 1 to this function, it's not defined. Can someone explain why?
ln of 1 is 0.
Yeah, because ln of 1 is 0. ln of 1 is 0. That's what we explained last time, right? This is. So, therefore, although this looks like a regular integral, the two bounds, 0 and 1, must be taken with care. You can't just do it like that. This must be reinterpreted as limit a going to 0 plus and b going to 1 minus. So you have like two variables that are happening at once. But you know, because these are plugged in separately, at some point you don't have to do two limits. It's really sum of two different limits. Okay. So it's going to be a to b of 1 over x times ln of x squared dx. And so for this integral, we have to do some more work. So usually when I do substitution, I try to say you have to not only change the function, but also the bounds according to it. But for this one, let me just integrate. Can I erase this? Okay. Let me just do the indefinite integral on this side. So we'll just do 1 over x times ln of x squared and see how this can be done by taking u equals to ln of x. Now if you have u equals ln of x, then du is 1 over x dx, right? So that dx is x times du. And therefore this interval will be like 1 over x times u squared, and dx is now replaced by x du. So x cancels, and you have to integrate 1 over u squared, which gives you negative 1 over u plus c. And then you go back to your ln of x as negative 1 over ln of x plus c. Yes?
So you have to reset the bounds.
So that's what I was trying to say. That if you're doing definite integrals, you should also change the bounds. But this has limits, and it's just too much trying to do everything at once. So I'm trying to break up the question by first doing the definite indefinite integrals first, and then use that result over here. Now we can just say this is limit a going to 0 plus and b going to 1 minus of the result of this integral is negative 1 over ln of x, and to this you're plugging in b and a, right? The antiderivative of this is this, so now we plug in b and a, okay? Now you plug in b, you get negative 1 over ln of b, limit b going to 1 minus, negative 1 over ln of a, but then a has to be sent to 0 plus. So that's a bit better. Okay, now let's do this one first.
Wait, Professor?
Yes.
So how does 1 over u squared turn into negative 1 over u?
Oh, that's because negative 1 over u prime is negative u to the negative 1 power. This comes down and it's negative times negative 1, u to the negative 2. Cancels. Negative is positive, so you get 1 over u squared. Okay, so the integral of 1 over u squared is negative 1 over u. It comes often enough that you might just memorize this. Okay? Okay. Now, let's try to deal with these limits separately. Let's first think about the limit b going to 1 minus of negative 1 over ln of b. To determine that, you need to know the graph of logarithms. This is the graph of ln of x. And from this graph, you should know 3 things. First, the x-intercept is 1. And then, as you take limit x going to 0 plus of ln of x, according to this graph, what happens? What's this value when you take x to 0 plus? It'll be negative infinity, right? Because you're like, let's say you're maneuvering this terrain, okay? And your supervisor says, go to 0, okay? And being a good soldier, you follow his old orders, right? And this is the 0 location, so you try to get there, but then as you go further, you're like falling down to the endless pit abyss. So you end up with negative. that's supposed to be funny. I guess not. All right. Okay, but what about the other cases? What would be limit of x going to infinity of ln of x?
ln.
But what is that as you go this way? Well, the slope does become less steep, but it still manages to go to infinity. So this would be infinity. And then this last one doesn't occur that much, but since we're at it, let's think about this. If you send x to 1 minus of ln of x, what would you get? You're approaching this location 1 from the left, right? So you're maneuvering this terrain from the left. So what's the value? 0. Your altitude will be getting closer to 0. So this gives you 0, but we want to be more specific than that because it's approaching 0 from negative or positive?
From the negative.
From the negative. You're going from below, right? So if you approach 1 from the left side, the value of log of x will approach from the negative side. Okay? And that's what we're going to use here, because then this would be negative 1 over 0 minus. So this is a negative value, that's a negative value. Overall, would this be positive or negative? Positive, right? Yeah, it's negative over negative. So it's a positive value. But what happens if you divide 1 by a very, very small number?
It's going to be a very, very small.
It'll be a big number.
It would be a big number, right? You divide 1 by 0.0001, becomes a big number. So you have a big number, so it will be positive infinity. Okay, so that part's at positive infinity. How about this other part? Limit of a going to 0 plus of negative 1 over ln of a. Well, we just did that. What's that limit in the bottom? Is this one, right? So this will be negative 1 over negative infinity. Right? What's that?
0.
So it's 1 over a positive infinity, which is 0.
Yeah. So you see that this goes to infinity, the other one goes to 0. So it's infinity. In other words, this integral does not converge. Okay? We say it diverges. Yes?
Sorry, is this example 3 continued? Is that like the...
Yeah, we started here and then we went over here. Okay. So that's a bummer. I mean, you put so much work to this only to find out that the answer is that it doesn't exist. However, I still want to say that this does have a tiny bit of information about this integral because it's not, at least it's not giving you negative infinity. It gives you positive infinity. Now, why is that important? That's because when something's squared, it's positive, right? Also, x would be positive from 0 to 1. So you're integrating over an interval something that's above the x-axis. Therefore, if it's infinity, it must be the positive infinity. It can't be the negative infinity. So like that does say something. Not much, but something. Okay, and actually calculating some integral to show that it's infinity will be an important fact that we are going to use for some series calculations a few classes later. Okay, so it's not like we're doing all this work to find that it doesn't mean anything. It actually means something. You'll find it.
So